Hey guys, it's Mrs. Rice. Today we're going to talk about similar polygons. So, I'm going to refer to something called corresponding angles or corresponding sides, and I wanted to make sure that you knew what I was talking about when I said that phrase. So, I just wanted to define that for you. So, corresponding sides or corresponding angles are a pair of sides or angles that are in the same spot when you're comparing the two different shapes. So if you look at these pictures, see how like angle A and angle X are the bottom like left angles, so those would be corresponding angles. Like B and Y are the top angles, so those would be corresponding angles. And then C and Z are the bottom right angles, so those would be corresponding angles. So they're in the same place when you're comparing the two figures. Same deal with the corresponding sides. J, K, and RS are in the same place when you're comparing these two figures. Like J, M, and RU are in the same place when you're comparing the two figures. So corresponding sides and corresponding angles refer to a pair of angles or a pair of sides that are in the same spot when you're comparing two figures. Now, the reason why that's important is because I'm going to talk about similar figures and characteristics. So if figures are similar, you're going to have two or more figures that are the same shape, but not necessarily the same size. Most of the time, one figure will be larger than the other. In order to determine if you have similar figures, three things have to happen. The first thing is that they have to be the same shape. You can't have a triangle similar to a rectangle. They both need to be the same exact thing. The second thing that you need is that each angle in one figure has to be congruent to an angle in the other figure. So that's where the corresponding angles come from. Each figure has to have a congruent pair of corresponding angles. And all of them. So like if you have triangles, for instance, each angle in one triangle has to have a congruent corresponding angle in the other triangle. And the third requirement is when you're comparing the corresponding sides, they all have to produce the same ratio. So what you would do is you would put one side over its corresponding side and simplify. And every corresponding pair of sides that you do that for will give you the same ratio. Okay. Next, we need to talk about when we actually write it down. So the symbol for similarity is a squiggle. So if you think about like a congruent symbol, it's like the squiggle above the equal sign. So you just drop the equal sign, just the squiggle you want to use. So they gave us two similar figures here. They tell us that ABCD is similar to GHIJ. So look for a second and see in this similarity statement, which is what this is here. See how they're different colors, like the first spot is in red, and the second spot is in blue, and the third spot is in green, and the fourth spot is in purple. So that's important because the letters in the same spots when comparing the two figures are the corresponding pieces. So that means A and G correspond, B and H correspond, C and I correspond, and D and J correspond. So we know that these two figures are the same shape. And if we look, angle A and angle G are congruent. They both have right angle boxes. Angle B and angle H are congruent. They both have right angle boxes. Angle C and angle I are congruent. They both have an arc mark. And angle D and angle J are congruent because they both have a double arc mark. So that's showing us our congruent corresponding angle pairs. Now the sides we know when we have similar figures will produce the same ratio. So what you see right here is an extended proportion. You're going to have as many ratios as there are corresponding sides between the two figures. So when I set up my extended ratio, I literally go through my angles first. I start at the top and I go to the next letter. So AB is what I put on top. GH goes over that because A and B correspond with G and H. And then I go to the next two letters. So BC goes over HI. CD goes over IJ. And when you run out of letters in order, you use the last one and the first one. They put it as first and then last, but I usually put it as last and first. It doesn't really matter as long as you're consistent. So I would have said DA over JG, but they did the same thing. They just did AD over GJ. So the way or the reason why they set it up this way is because they know when you compare the corresponding sides for every piece of these figures, it will give the same ratio, and that's why this is the extended proportion. The ratio that they give you is the scale factor. That's also sometimes called a similarity ratio because, again, you're dealing with similar figures. So if these were numerical values, you would see they would all equal the same number, and that ratio is the scale factor. Or, again, another name of it would be the similarity ratio. Okay, so here's our first example. So this is identifying corresponding angles and sides in a similar figure. So basically, I want you to be able to look at a similarity statement and know how to set up the corresponding angles and sides. So if we look, first spot here is M, first spot here is S. So angle M and angle S are congruent. Second spot is N, second spot is R. So angle N and angle R are congruent. Third spot is P. Third spot over here is T. So angle P and angle T are congruent. So you'll see that over here. I literally just went first spot with first spot, second spot with second spot, third spot with third spot. You always want to list the angles first. That'll be the easiest thing to do before you list the sides. Again, from there, when I do the sides, I literally go down this line. So MN are my first two here. SR are my first two here. So I would put MN over SR. And that would equal, so then I go to my next two. NP over RT. There you go. And then our last one, I do the last one and then the first one because we ran out of letters otherwise. So PM over TS. So that's how you use the similarity statement to match all of the corresponding pieces. And then our last thing we're going to talk about, and I have two examples for you, are determining if figures are similar. So again, have to be the same shape. These two things are the same shape, so that's good. Then we have to find matching angles that go together. So let's see. J and T both have double arc marks. That's good. K and U are both right angles. That's good. L and V both have triple arc marks. That's good. And then M and W both have a single arc mark, which means that all corresponding angles are congruent. That's what we want from the angles. If that doesn't happen in your picture, then you can automatically say that they're not similar. Okay, now we have to go and see what the side lengths have, because again, we need to make sure they all equal the same ratio. So the first thing I'm going to do is I'm going to do JK over TU. So JK is 12, TU is 6, 12 over 6 simplifies to 2 over 1. So our ratio right now is 2 over 1. If we have a pair of corresponding sides that do not give us that ratio, then we can automatically say these are not similar. So let's go to the next one. So I'm going to KL over UV. So KL over UV, KL is 24, UV is 16. Simplifying 24 over 16, we get 3 over 2. So because this number, 2 over 1, doesn't match this number, 3 over 2, we can stop here. Because the minute that our ratios do not match, we can automatically say that they're not similar. So, although the angles gave us congruent corresponding pairs, the sides did not produce the same ratio. So we would say no, JKLM is not similar to TUVW because the sides are not proportional. And again, what that means is that they don't give you the same ratio. Okay, and then our last example. So we need to look at the two triangles. So they're the same shape, so good. They have two triangles here. So now let's look at angles. So angle A, which is a double arc mark is congruent to angle D because that's a double arc mark. Angle B, which is a triple arc mark, is congruent to angle E because that's a triple arc mark. And then angle C, which is a single arc mark, is congruent to angle F, which is a single arc mark. So all of our corresponding angles are congruent in these two figures. So let's move to the sides. So I'm going to do AB over DE first. So AB is 12, DE is 15. So 12 divided by 15 simplifies to 4 over 5. That's our magic number right now. We're looking for 4 over 5. So let's go to BC over EF. So BC is 16, EF is 20. So simplifying that would give us 4 over 5. So you may want to stop here and go, oh, well, 2 out of my 3 work, but make sure you do all pairs of sides because sometimes they like to wait till the very last one to be like, ha, fooled you, and you always want to make sure you have all of your work shown. So the last pairing would be CA and FD. So if you look, CA is 8, FD is 10, and that does in fact simplify to 4 over 5. So these triangles are similar. The similarity statement would be triangle ABC is similar to triangle DEF. So I always use the angle setup over here to help me write my similarity statement. And then our scale factor would be this ratio here, which is 4 over 5. Now, if you have 5 over 4, meaning like if you put DE over AB and EF over BC and FD over CA, that is perfectly fine because they did not specify how they wanted you to set up your scale factor. So if you had 5 over 4, that would also be correct. Okay, guys, so this is the similarity section part of it that I wanted you to make sure you wrote notes for. I hope you followed the worksheet that I gave you and answered all of the questions. Make sure you answer the question about clarifying anything in case there's something on here that's confusing to you. Have a great day, guys. Bye.